All right. Hey guys, I got a real joke for you today. I'm supposed to be in Hawaii, but I'm not because I had COVID. All right, let's get to it. Okay, so today's lesson, factor theorem consequences. It's basically an extension of what we did last lesson on factor theorem. There's three main things that I'll touch on. First one, if A, B, and C are zeros of your polynomial x, then x minus a, x minus b, x minus c, they're going to be your factors. And your question that you could get could come up a little like this. They'll say, find a monocubic polynomial with zeros minus 1, 2, and 5. So in other words, your polynomial can be written like this. It's just going to be x minus 1, x minus 2, and x minus 5. And just cleaning that up, that becomes x plus 1, x minus 2, and x minus 5. There you go. Okay. When you expand that out, you're going to get a cubic, and we've got our zeros, -1, 2, and 5. All sweet, all good. First one done. All right. Second one, if a polynomial has a degree, whatever that degree is, that's as many zeros as you can have. So for example, if you had x squared, at most, you're going to have 2 zeros. All right, at most. And then if it's x cubed, you're going to have 3 zeros at most, okay? Now, it could be less, but we're just also working with at most, you're going to have that many. Okay, now the last one is probably the one that's going to take the most amount of work. Now, if your polynomial has the same coefficients and powers of x with qx, then px equals qx. Kind of makes the same. So in other words, I'm saying that this is one polynomial. And the other side there's your other polynomial. And I'm saying that if we can equate things and make them the same, then they're the same. Now, the easiest way to kind of solve A, B, and C here, find A, B, and C, and D. First things first is let's see what happens. If you take a look here, if we let x equals to 2, we're going to get a lot of things turned to 0. So if x equals to 2, then we get 2 cubed, take away 2, should equal to, technically, that'll cancel, that'll cancel, that'll cancel. Just leaving us with D. And from there, we can get that D should be the same as 6. Now, once we know that, let's keep going and see what else we can find. Let's take a look at the x cubed. I guess there's not really much to do here, but let me go here. If I go from there, I can see that that's going to give me my x cubed, and I'm going to have ax cubed. And from there, I can see that ax cubed is supposed to be the same thing as x cubed. So in this case here, a is just going to equal to 1. Okay, now B and C is going to be a little bit trickier. Let's let, in this case here, B and C are kind of like x to the power of 2 and x to the power of 1. So in other words, let's just let x equal to 0 in this case here. Letting x equals to 0, what we're going to have is we're going to have 0 equals 2. And just letting everything that we know, it's going to be 1 times -8. And then it's going to be plus b times 4, so plus 4b. And then substituting 0 for this one is going to be minus 2c. And we found out that d was 6, so it's just going to be plus 6. And we know that, I guess from there, what did I do wrong here? Oh no, that's fine. So it's going to be minus 8 plus 4b minus 2c plus 6 equals to 0. So 2 is going to equal to 4b, take away 2c. And from there, I can also divide everything through by 2, giving me 1 equals to 2b, take away c. Okay. And probably the other one that would be interesting for us to look at is letting x equal to 1. And if we let x equal to 1, because we're going to also get something that equals to 0 here, because the left-hand side will be 1 cubed, take away 1, which equals to 0. And that's going to equal the same thing as, once you substitute everything and put it all in, it should equal to -5. Okay, now I'm not going to go through it for this example, but you just substitute it all the way in. And so from there, hold on. Let me fix that up a little bit. So 0 is going to equal 2. You're still going to have that -1 from the A. And then you're going to have 1 take away 2. That's -1 squared, which is going to be plus B. You're going to have 1 take away 2, which is -1 minus C. And then you got your plus 6. All right. So from here, rearranging what you should get B minus C equals to -5, because -1 plus 6. All right, then I'll just move the -5 to the other side. So maybe the better way to write this would be B minus C equals to -5 that way. And then we can solve those simultaneously because there's 2 equations and 2 unknowns. And from there, we should be able to get B equals to C minus 5. Substitute that into the other one. 1 equals to 2 bracket C minus 5 minus 2C. So 1 equals to 2C minus 10 minus 2C minus C. No. Minus C. That's it. So we get C equals to 11. And from there, we can also get B equals to 6. So there you go. A equals to 1, D equals to 6. And boom, we did it. Took us a while, but that's how we do it. All right, enjoy. I'll catch you guys later, and bye-bye.